I want you to know that I only do this because I know you can. There's nothing different that you see here than what we've already seen. I want you to tell me everything you know about this graph.
Oh, it's going down in the cross, like moving from the origin.
Now, remember what your key points were. Your key points were these little guys right there, right? Easy way to remember that, you start at the origin, then you look at your perfect squares, 1, 4, and 9 units out. Okay, so we're looking at something that has this kind of shape because of the square root. What else do we know about it?
Goes down 3.
We know that we're going to be going up 3 because this guy's outside. You do exactly what you see. It's a horizontal shift, a vertical shift, excuse me. What about the plus 7? I'm going to go to the left 7. Inside, horizontal, opposite of what you see. What about the negative 2 up front?
The negative.
Negative means instead of doing this, it's going to do what?
So go the opposite way.
So it's going to be upside down. It's going to look something like this, right? What's that 2 going to do to it? Since that's a value greater than 1, this corresponds to a stretch. Do y'all agree with that? So there's nothing different here than what we would have had if this were absolute value. Just imagine. If I had said f of x is equal to negative 2 times the absolute value of x plus 7 plus 3, would you know what to do with that guy? You know where to put the vertex. You know you're going to stretch it. It's upside down, right? I'm doing the same thing, but now I have to deal with a different shape. I told you were going to see things like this, especially when you go into college algebra. You start adding to the library of functions that you learn. So where's my base point? It was at the origin. Now where is it?
Said 3, 7.
It's not 3, 7.
3, negative 7.
Nope. Left 7 and up 3. I'm going to start right here.
Oh, 7, negative 7, 3.
You guys with me? So I've used this guy and I've used that guy. When we were doing these back in the day, remember how we would do this? As though that were my new origin. Remember that? So you have to know your key points. Your key points are not 0, 1, 2, 3, 4. Your key points are 0, 1, because that's a perfect square, right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You guys with me on that? I'm picking out these as the key points from my base point because these are my perfect squares because I'm dealing with the what? Square root. Does that make sense? Now, if I were just doing a very rough sketch, my little halvesy parabola would be coming down like this, right? Opening down. Let's find out what those exact points are. What's the square root of 1? Square root of 1 is 1. I'm going to put an x there, but that's not my point. Why not? Because aren't I supposed to be stretched by this 2? So my real point is going to be 2 units down. What's the square root of 4? Square root of 4 is 2, so the normal graph would have been down here when I apply that negative, right? But now how far down am I going to be? I'm going to be down a total of 4 units because I'm doubling that because of the 2, right? When I come out here to 9, what are you going to do? The square root of 9 is 3, but you have to move down 6 total units. What's the square root of 16? Square root of 16 is 4, but I need to move down 8 total units because I'm doubling this guy, right? See that? I'm doubling that. If I had not applied this stretch, then you would have had a graph that looks something like that. But now that I did apply the stretch of 2, this is my graph right here. Notice that this point is a beginning point. It doesn't have an arrow, but it does continue out forever in this direction. Other questions about the graph that I have here? You see how it's been shifted to the left 7, up 3. I applied the negative, so I'm opening upside down, but then I applied a stretch, which is what makes it steeper, right? Now my question to you is, what is the domain? Since I had stuff on the inside, remember I had over? The D for I had meant domain. I can affect the domain. And since I shifted to the left, I did affect my domain. So what is it now?
-7 to infinity.
Including -7 and going out to the right to infinity. What is your range?
-infinity to 3.
This guy's going all the way down here. So he's coming from -infinity. The highest he gets is the y value of 3. Okay. What questions do you have about that guy? Is this any different from the graphs we had before? No, the only thing that's different here is a different set of points, a different set of key points that you need to know and have memorized. That way you're not having to figure all this stuff out and do a t-table every time. I know my key points. The square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, and so on. So these guys were below because of the negative, and then I stretched them by the factor of 2. Of course, if you're not sure about things, check out your calculator. If I were to graph -2 times the square root of x plus 7, and notice, this open up parentheses. Some versions of the calculator don't have parentheses to open here, so you always be mindful of that. Close them off, and then plus 3. I need to change my window a little bit. Let's go back to the standard zoom-in window. Well, doesn't that look close enough to mine that you'd believe me? Or do you just not like this at all, so you're going to distrust technology completely? Okay. Terminator 2 is happening.